Hello everyone, this is my Physics 1 lab. My name is Max Trigup. For this lab, I performed this lab to observe how position, time, and velocity are interrelated, and I utilized Newton's laws of my knowledge of Newton's laws of motion and the definitions of position and velocity. So what that means is sigma F equals ma. I utilized that, and the fact that velocity is the derivative of position, and that position is uh, position where something is located, and velocity is change of position over time. In this lab, I discovered that velocity is the slope of the graph of position over time. There we go. And I derived the equation v equals x over t from this information. Before starting my lab, I assumed that the marker speed was always constant. There was no friction between the marker and the table, and the meter stick appears as 1 meter long in my recorded video. Of course, there's perspective effects, especially with a camera lens, but I ignored them and just assumed that everything in the video is proportional and that there was no friction with the table. But as you'll see, friction played an effect on my marker's motion. For my procedure, I rolled an expo marker approximately 1 yard at a constant speed. I tracked the marker's position over every frame of the video that I recorded. I compiled the position values into a spreadsheet. I recreated my experiment in GlowScript in the Python code and exported those position values into the same spreadsheet. And then I graphed both sets of values and compared the actual position over time of the marker and the expected position over time of the marker. The actual position over time is what I got in Tracker and what I actually recorded, and the expected position over time is the GlowScript code and the file and the exported data values that I got from GlowScript. This is my video of my team rolling the marker. As you can see, we rolled it along the meter stick. The video can't play, but you can imagine what a marker rolling across a meter stick looks like. This is the code that I used in GlowScript with my inputted position, velocity, and change in time values. The position and velocity values are both negative because we rolled the marker from right to left, and using a traditional physics coordinate system, plus x is in the rightward direction and minus x is in the leftward direction. So since it's rolling left, it's going in the minus x direction. That means its velocity is negative and its position is decreasing in value but increasing in magnitude in the negative direction. This is my graph of both the positions in Tracker and the positions in GlowScript. As you can see, the positions in Tracker have the graph of the positions in Tracker has a less steep line than the graph of the positions in GlowScript. I discovered that position and time have a linear relationship when acceleration is constant. The linear relationship is velocity. Velocity is the slope of the graph of position over time. The force of friction is acting on the marker. The marker's actual velocity is less than its predicted velocity, and that the GlowScript graph's slope magnitude is greater than the Tracker graph's slope magnitude. So this last detail is key to this whole thing because it proves that there is a force of friction acting on the marker. We just negate it and ignore it. But because the slope is smaller and because slope is velocity, for the actual velocity, the actual velocity is less than the predicted velocity, and there is a force opposing the original motion.